So this is the hints for the National 5 homework sheet 23. In the first question you asked to evaluate 3 times 1.5 minus 0.8 times divided by 2. Now in this question you're required to use BODMAS. So that means that you'll split the question into two parts. You do the 3 times 1.5 first, and then you'll take away the answer to 0.8 divided by 2. In question 2 you're asked to evaluate 20 minus 4x squared y, where x is minus 1 and y is 3. Just a wee substitution question, so you replace the x with minus 1 and the y with 3, multiply out your answer and then fully simplify. In question 3 you're asked to evaluate 3 1/5 take away 2/3. First thing we need to do here is we need to turn 3 1/5 top heavy. Do that by multiplying the big number by the bottom, adding it to the top. You're then looking at a common denominator for both fractions, so what's the first number in both the 5 and the 3 times table, and that's 15. Okay, so you can have a common denominator of 15, and then you'll work through the question fully simplifying. Question 4, we're asked to factorise 3x squared minus 5x minus 2. We do that by drawing a wee table at the side. We take our factors of 3, which are 3 and 1, and they go to the top of the table, and then underneath we take our factors of 2, which are 1 and 2, and because the numbers at the top of the table are different we have to rewrite these factors again. So because it's a trinomial it'll be a double bracket, and the minus in front of the 2 tells us we're going to have 1 bracket plus 1 bracket minus, and you use your table to figure out what goes in each bracket. In question 5 we're asked to find the equation of a straight line in terms of t and s. So what we have is we have 2 points. We have the point 10, 3 and we have the point 4, 0. For the equation of a straight line we need to find the gradient, so we calculate the gradient by doing y2 minus y1 over x2 minus x1. Then you substitute it into the formula y minus b equals mx minus a. Now you'll notice that it says in terms of t and s. Okay, so we're going to take the formula y minus b equals mx minus a, and when you get to the finishing stage you'll have something that looks a bit like y equals mx plus a number at the end. To write it in the equation of t and s, as you can see that your y has been replaced by t and your x has been replaced by s. So your equation of a straight line will be t equals ms plus c, where you replace the y with a t and the x with an s. In question 6 we're looking to solve the inequality 5x minus 4 is less than 2 bracket x 1 minus 2x. So the first thing we would do here is multiply out the brackets. Okay, so 5x minus 4 is less than 2 minus 4x. We then want to move our x's to the left hand side and our numbers to the right hand side, so that I'm just left with x on its own at the end of the question. For question 7 we're told that f of x is equal to 3 to the power x. So for f to the power of 4 I've replaced the x in the bracket with a 4, so that means I also have to replace the x in the question with a 4. So it's 3 to the power of 4, which equals, I'll let you tell me. And for part B we're told that f of x is equal to the square root of 27, so that means that 3 to the power of x is equal to root 27. Now the square root has a special power, which is x to the power of a half. Okay, so that means that our value of x is going to be a fractional value. Okay, now because we've taken the square root, it means it's going to be a number over 2. Okay, so what do you have to do to 3 to get to 27? and that's what will go in the gap there. So it's going to be a fractional value, something over 2. In question 8, Paul bought a new car last year. It's fallen by 12.5% since then. It's now valued at £10,500. How much did they pay for the car? So if it's 12.5% decrease, we take that away from 100. So that means that 87.5% of the original value is £10,500. We then need to find out what 1% is by dividing by 87.5 times by 100 gives you the original value of the car. So in question 9, we're looking to find the distance between 2 oil rigs, which is the dotted green line I've drawn in here. Now we know that the first oil rig, Delta, is on a bearing of a distance of 35 kilometres away on a bearing of 50 degrees. Now that means this small angle in here is 50 degrees, and that's to your Delta oil rig. We also know that a second oil rig, Gamma, is on a bearing of 125 from the north line, and it's 20 kilometres away. So that full distance is 125. So we know that angle there is 50, and that the whole angle is 125. So because we're working with a triangle here, we've got to use the cosine rule, but we need to find this angle in here. So 50 plus what is equal to 125. That gives you the angle in there. We're then finding this side here using the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. In question 10, we're asked to solve algebraically the equation 2 plus 3 sin x equal to 0. First thing we want to do is we want to take over this 2 so that we're left with the sin x term on the left hand side. So we know that 3 sin x is equal to minus 2. Then we need to find out what sin x is, and then we find out our angle. Now we need to use our cast diagram, and you find out if sign's positive or negative by your answer from here. You take the 2 quadrants that applies to. So if it's positive, it's going to be in the first 2 quadrants, A and S, and if it's negative, it will be in quadrants 3 and 4, which is T and C. You then use your angle fact to calculate the 2 angles. In question 11, we're told that the end of the bungalow is in the shape of a triangle and a rectangle is shown in my diagram, and we're looking for the length of the longest sloping edge. So it's here, I'll call that x. Okay. Now what we need to do here is we need to fill in parts of the diagram we know. We know that the length of the bungalow is 12.8. So if this wall here is 12.8, then that must mean that the wall at the top of the bungalow is also 12.8 metres. Okay. Now we have 2 sides of our triangle, and we've got 2 angles, so we'll be looking to use the sine rule. Now the one problem I've got with this is that I don't have the angle opposite the 12.8. Now I'm going to need that for my sine rule, so what I have to do is I have to figure out what this missing angle here is before I use a sine rule. In question 12, we're told that the gardener creates an L-shaped flower bed. He uses house walls and concrete edging for his boundary, so that's my dotted line in here. We're told that AB is equal to ED and BC is equal to DC. Now we know that ED and AB are both X from the diagram, and one thing we need to put in is we need to put in that he uses 6 metres of flower bed, 6 metres of edging. Okay, so one thing that's missing from the question I just noticed now is that he uses 6 metres of edging. Okay, so you need to stick that in. So if you use 6 metres edge, and we know that AB plus BC plus DC plus ED is equal to 6 metres. We know that AB and ED are both value of x, so BC plus DC is equal to so BC plus DC plus 2x is equal to 6. So your side's BC plus DC must be equal to 6 minus 2x. Now that's not the answer we're looking for, so how do you think you show that both the sides are 3 minus x? So once you've done part A, and you've calculated, or you've shown that these sides are both 3 minus x, we're then asked to find the area. Now we can't find the area of an L-sided shape, so what we have to do is we have to split it into two areas. So area 1, area 2. Now they're both rectangles, so it's length times breadth for both of them. You know your dimensions, and to find the total area, you add your two answers together. Now for part C, we know that the area is equal to 6x minus x squared, and it's asking for the maximum area. Now 6x minus x squared is a minimum parabola. Okay, so the maximum area will be your x coordinate of your turning point. So for the parabola 6x minus x squared, find the turning point and then substitute in your maximum value. That will tell you what your maximum area can be.